So the two warm-ups that you have on the left-hand side, they disappeared on me. So I need you guys to take a look at that first warm-up. It says the purchase Ty, excuse me, you're good. Really, I have lots of practice doing this. Turn that around. Ty, purchase a car. Don't cover it so I can't see it. Let's try this again. Ty purchased a car for $22,900. The car depreciated at an annual rate of 16%. Which of the following equations models the value of Ty's car after 5 years? Now, does everybody see the percentage in that problem? Which means that your equation better look like this, correct? Do all of those equations look similar to that? They do, right? Okay, so what was the starting price of my car? So that's my B. Now, did this thing go up or go down? Down by what percentage? So I started 100% and I go down 16%. What percent am I at now? 84%. But folks, I cannot use this 84 as it is. We move the decimal place 2 spots, and now it is 0.84. And how many years is this happening for? So do you have a choice that looks like that? Letter D, as in shoot dog? You will, yes, eventually. Oh. Start charging him $1 every time he wants to use it. No, go ahead. Guys, gentlemen. Okay. Get with me here. Thank you. Can you please type this in your calculator and tell me how much that car will actually be worth after 5 years? Now, whether you know this or not, cars depreciate in value very, very quickly. It shouldn't be negative. I can't have a negative price of a car. Go ahead. Down. And 5 cents or 50 cents? So like this? Okay. So that car went from almost $23,000 down to almost $9,500 in 5 years. It is a lot. Okay. All right. Take a look at the next one. Right below it, please. I have a deck. And it measures 12 by 18. Can you all draw your deck, please? 12 by 18. Does it matter which side the 12 and what side the 18 goes on? No, it does not. I want to paint this deck. Now, folks, if I'm going to paint this deck, do I need to find the area, perimeter, or volume? Area. How do you find the area of a rectangle? Awesome. I will tell you, and if there's any 4th period people that end up listening to this recording, 4th period could not tell me the area formula for a rectangle. You should know this just fine, right? Okay. So you know the length, you know the width. Can you multiply them, please, and tell me what... Okay, at least let me ask it. 216 is what you get for your area. Okay. Now, I have somebody that's going to come do this painting for me. How much are you going to charge? Per square foot. So I know that I have 216 square feet that need to be painted. Derek's going to charge me $265 per square foot. What are you going to do with those numbers? You are going to multiply them. No. How much am I going to be paying Derek? And how much? 40 cents, like that. Now, you probably got to buy your paint and your paintbrushes, but then the rest of it's your profit. Okay. Everybody doing all right here? Does anybody have any questions on this? Okay, let's go across now to the other side. Take a look. Now, I have come to find out from 4th period that you guys have not done a whole lot with scientific notation yet. You should have seen it before, and don't worry about the question. Does everybody remember seeing something like this? Scientific notation where you have some number times 10 to a power? Does this look familiar to you or not? Yes. Or something like that? This is scientific notation. Now, again, this is just going to be a quick crash course in scientific notation. This number here, is always between 1 and 10. Okay, this number over here, if it's a positive power, why don't you guys do this actually? Type this into your calculator. 3.14 times 10 to the 7th. Big, big, big number, right? Yes? Okay, now take this number and type it into your calculator. Should be a little number because this power is negative, this power is positive. So what scientific notation does, it allows us to write really, really big numbers and really, really small numbers. An example, in science class, we have numbers that could be really, really big and really, really small. They use scientific notation. Fair enough? So can you take this scientific notation and turn it into a regular number? What's wrong? Can you take that number right there and turn it into a regular old number? What do you got? It should be that one. Your calculator should spit out that number for you. You did it. Are we A-okay here? Okay, last but not least, we have this question about Tony leaving school. Tony left school and rode her bike home. The graph below shows the relationship between her distance from school and the time. So let me ask you this. How far away from school did Tony start? 0, because she's at school. So she's 0 miles away from school. That should make sense, correct? Okay, so I want to know the explanation of the graph from x equals 30 to x equals 40. So go to where x is 30. Go to where x is 40. I want to look at the graph between those two times. Does everybody see it? It's a horizontal line, isn't it? So I want you to read your choices, F, G, H, and J, and decide what does that horizontal line mean? Is she moving? Is her distance getting farther away from school? It's so she is stopped somewhere, correct? And that would be letter H. Does anybody have any issues here? No? We're all good? Yeah, graph reading and science probably got you a lot of background knowledge there. All right, let's take a look at a graph, and this is kind of what we started with yesterday. Now, we have already talked about increasing and decreasing on a graph. Okay? Well, actually, probably with half of you, because the other half of you weren't here. But some of you have talked about increasing and decreasing. Guys, what does increasing mean? And decreasing? Now, when we look at a graph, we read a graph from the left side to the right side. Does everybody understand that? Please do not pay attention to the arrows on the graph. So if I go from left to right, what does my graph start out doing? Is it going up or is it going down? It's going up. We start here, and this thing is going up. When does it stop going up? Right there. Now, we only want the x value. So what's the x value there? So would you say this is before 2 or after 2? Before 2. So it is increasing before 2. And then what happens after 2? It decreases after 2. Now, let's write this in a little bit more of a mathy way. If I am before 2, is that numbers that are less than 2 or greater than 2? So that would be x is less than 2. And if I'm after 2, that would be x is greater than 2. Does anybody have any issues with that terminology? Everybody's all right? No, we don't want the y values. We only want the x values. Okay, now we talked about this yesterday as well. So Tyler and Sarah, this is something that you missed yesterday. Let's go down here. It says, what are the values of? How do you read this? Nope. F of 0, correct? Now, normally, don't we see it as f of x? But what is this 0 right here? It's the x, isn't it? See how it's in the spot where the x is? So go to where x is 0. Would be right there. What's the y value? 0. Okay, now this says f of 4, so this means x is 4, right? Go to where x is 4. 1, 2, 3, 4. And that would also be 0. Now this says f of negative 1, so go to where f is negative 1 and follow it down to the graph it would be, oh, how about -5? Does that make sense to you too? Yeah? Okay, let's go back up then and do this other one. This says f of x equals 0. Now, folks, do you have something in there for the x? That's just x, isn't it? So I don't know the x, but this one must be the y. Is that okay for everybody? I don't know this x. Do I see how it's still an x there? This is the y then. So go to where y is 0. What's the x value? 0. This one says f of x is -5, so go to where y is -5. Now here's where I have an issue. Does everybody agree that right here is where y is -5? That's where y is -5, right? So I either could choose this point or this point because both of those have a y of -5, don't they? I need both of them. So what is this x value? And what's that x value? And 5. -1 and 5. That one has 2 answers. And then lastly, this says f of x is equal to 4. So go to where y is 4, follow it over to the graph, and the x value would be 2. How is everybody on the front of that sheet? Does anybody have any questions for me? No? Good. Okay. Let's go to the back. So this was the new stuff that we talked about yesterday and where this kind of came from. Okay, so let me know if you guys have any questions. Can you guys tell me what a linear function looks like? Now, it's not going to be y equals because it says function. There we go. F of x equals mx plus b. Is that all right for everybody? Function just means f of x. Now, when you graph this line, we start at b, don't we? And then we use the m to go up and over, up and over, up and over, right? Okay. Does that up and over ever change a middle of the way through? It does not, because this is used to represent consistent change, meaning it does the same thing every single time. Okay, that is what it means to be linear. We have introduced this new thing called an exponential function. And exponential functions look like that. Okay, the b is your starting number. The a is your percent of change. Okay, because these things are typically used to represent percent of change, which is why all of those questions in your homework last night had percentages in them. That's the clue right away that you go to this type of equation. Yes, sir. The b is your beginning number, and this will be in your recording from yesterday when you go back and watch it. And the a is your percent of change. Okay, so we are basically doing exactly what we did yesterday. The first thing we're going to do is write a function, and then we're actually going to find the answer. Fair enough? Okay, so read number 1 down there to yourself. Yep, same thing as yesterday. Writing a function, then we're going to plug in a number. Yeah. I mean, if you want. Do you have variables given to you? You do not. So we are always going to default back to f of x. Okay. Now, do we have a starting number? What is it? There are 310 people that started out with this magazine subscription. That's the B right here, that 310. Now for the A, I need to know what happened. Did the number of people go up or down? Up by how much? So I'm going to go up by 15%, and I always start at 100%. No matter what, the base is always 100%. If I go up by 15, now I'm at 115. But folks, you can't use this 115 the way it is. You have to move the decimal place 2 spots. And if you do that, it will be 1.15. And that's the number that represents the A over here in that equation. Okay? Now we're going to raise that to a power. Well, if I'm using f of x, it's going to be x. That's the function. So did I follow you guys with all that okay? Now we're actually going to plug something in. How many years went by in this situation? From 1999 to 2019 is 20 years. So you're going to take that 20 and you're going to plug it in for x. Okay, hold on one second. How's everybody doing with where I put that 20? Good? So you pick up your calculator, you type it all in, and you should not have a decimal here. Okay, you have to do rounding if you do have a decimal. What's up? You waving at me? I'm going to take Savannah's here. Go ahead, Savannah. Like that? Okay, so how'd we do getting the number? Thank you, ma'am. Tyler, are you okay with that number? At the 1.15? Okay, so do you get how we got to 115? So right now, the decimal is behind that 5. You have to move it 2 spots. So 1, 2, now it's 1.15. Always. Always, yep. Yep. Sarah, how you doing? Good? Everybody else is doing okay? Good? Moving on? Yeah? Okay, read the next one. Read the next one. I need to know if I have variables. No variables for this one again? Now, don't go ahead on me on this one, please, because this one's a little different. So I'm going to use f of x. Do I have a starting number? How much? I'm starting with $12,000. What happens to my money? It goes up by 5%. So I started 100. Yes, going up. So I'm growing by 5. So does everybody agree now I'm at 105? But remember, I can't use this number. The decimal point is behind the 5. Move it 2 spots, and I'm now at 1.05. Tyler, is that okay? To the x power. Now, here's where it gets different. Okay, we have not done one of these like this yet. How many years went by in this problem? 15 years. But do you see how it says this happens every 5-year period? We don't put a 15 in there. How many 5-year periods are in 15? 3. So we are actually going to be putting in a 3. Does everybody see the difference in this problem? Yes? In all of the other problems that we've done, it says every year. Okay, this says every 5 years. Dylan, do you have that number for me? What's your 50 cents, like that? Did you round appropriately? Actually, I think it's 50 cents even, yeah. Okay, so how we doing? Good? Dalton, you okay over there? You're quiet today. We're okay? Everybody else is all right? Doing okay? Easy enough, right? Okay. Go ahead and read number 3. Do I have variables? No, so we're going to default to f of x. Do I have a starting number? What is it? 3. I start with 3 bacteria. What happens to those 3 bacteria? Do they go up or down? They go up. Now, folks, you do not see a percentage in this problem, do you? But this doubles right here indicates that you are going to use a percent. Now, what percent do we start at? If I double it, I'm now at 200, but you cannot use the 200 as it is. The decimal point is back here. Move it 2 spots. What number are we actually using? We're actually going to use a 2, and this will now be to the x power. So what if you were going to triple something? It'd be a 3, wouldn't it? Because it'd be 300, move the decimal, and now it's a 3. How long is this happening for? 5 hours. So we're going to take out the x, and we're going to put it a 5. How many bacteria do we have after 5 hours? 96 bacteria. You ever seen the movie Outbreak? No? It's about a monkey that infects everybody. I have never seen that movie. Okay. Okay. All righty then. All right, moving on. Take a look at number 4. Do you have variables? Ooh, I have 1. So how are you going to label this? F of t, correct. Do I have a starting number? College is going to cost me... Okay, what happens to this cost? So I'm going to go up by 5, which is 105, which is going to turn into what, Derek? 1.05 to the t power. T power. Now, how long? That was an easy one, right? 15 years. Now, I want you to, don't tell me the number that's on your calculator. I want you to look at it, okay? Because we're going to ask ourselves a few questions about this number. First of all, I want to know if my answer makes sense. Was my cost of college supposed to go up or down? Did it go up from $10,850? Yes. Now, did it increase by a big percentage or a small percentage? It increased by 5%, so it should have only gone up a little bit. Did it only go up a little bit? Well, consider where we started. If I start at 10,000, going up maybe 1,000 or 2 isn't very much at that point, is it? No. So hopefully your answer makes sense. And I think it's like 12,000 something. Excuse me. 20. Do I have the wrong number in here?
That makes me sad. Yeah, I did 15.
What's that?
6 to the power of 15. Well, it's for 15 years.
So that does make sense because it's over 15 years. Yeah, I think you're right there. How's that, guys? Folks, how is this? Well, remember, this is over 15 years. So every year, if it goes up a little bit, then now that makes sense, doesn't it? Yeah. I know. Guys, this is what's happening to the cost of college. It's kind of crazy. Kind of crazy. Okay, last one. Last one, please. I need to know first if we have variables. Nope, so we're going to default to f of x. Do I have a starting population in this city or county? Excuse me. Now, what happens to my population? So I started at 100, and I'm going to go down by what? So if you go down from 100 by 0.3, where are you at now? Everybody doing okay? Now, I can't use this number the way it is. I have to move the decimal place 2 spots. So now it's 0.997 to the x power. How are we doing with that crazy decimal in there, okay? Fine? All right, how long is this happening for? 10 years. Now, again, I don't want you to tell me the number. I want you to look at it, and I want you to see if your answer makes sense. Should your number have gone up or down? Down. So look at the number you have. Did it decrease? Now, did it decrease by a large or small percentage? Really small, right? So it really should not have gone down a whole lot. How's the number look on your screen? Does it look okay? Okay, what do you got? Like this?
No, there's no point. You gotta round it down.
Just 23, like this? Is that all right? How we doing, guys? Does anybody have any questions on exponential functions? So when I see you next on Wednesday, we will be reviewing, and then Thursday will be your test over Chapter 7. That's going to be all the exponent stuff. When do we multiply them? When do we add them? When do we subtract them? Outside powers and over that. That's all on your test, so we'll review that on Wednesday. Everybody good? Hold on a second. Homework. Very short. Very short. No. Not very many. plenty of time to start this. Get the books out from under your desk. Get a piece of paper if you need it. And get something to contest. Yeah, regular paper. There's a whole stack on the card over there.